All right, we've got one more type of transformation that we're going to look at today. And let's start by sketching a couple of graphs to see what's going on. Let's sketch graphs of f of x equals the square root of x. I know, mixing it up, not doing x squared. And g of x equals the negative square root of x. All right, we'll make our tables of values, and we'll start with f of x. Now we know this function, we've graphed it before. The domain is x is greater than or equal to 0. So we can pick 0, 1, 4, and 9. Those are the nice x values because they're perfect squares and we can take the square roots. The square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3. We could pick more values, but honestly, I think this is going to be enough to illustrate the point here. So we can also make a table of values for our transformed function, g of x. Now here, the only difference is that instead of taking the square root of x, we're going to take the negative square root of x. So we can pick the same x values, and then let's start at the bottom and work our way up. The negative square root of 9 is negative 3. The negative square root of 4 is negative 2. The negative square root of 1 is negative 1. And the positive or negative square root of 0 is just 0. 0 is the only number that has only one square root. Doesn't matter if we put a plus or minus out front, it's still 0. Now let's get an xy plane. We'll graph both of these functions and see what this negative out front does to the graph. So for the square root of x, we've got 0, 0, 1, 1, 4, 2, and 9, 3. And we know that the graph looks like this, and it's effectively half of a parabola. Let's take a look at the graph of g of x, though. We've got 0, 0, we've got 1, negative 1, we've got 4, negative 2, and we've got 9, negative 3. And if we sketch this graph, we end up with kind of the other half of the parabola. But what happened from this first graph to become this second one? What's going on? Well, we are reflecting the graph across the x-axis. Every point here is reflected vertically to the other side of the x-axis. And so, when we have a negative somewhere in a function, this is going to act as a reflection. Before, when we were adding or subtracting numbers, we were shifting or translating up, down, left, or right. Here, when we've got a negative somewhere, we are reflecting about one of the axes. Let's write out this rule, and let's do another example. To sketch the graph of y equals negative f of x, reflect the graph of y equals f of x vertically about the x-axis. So we've taken this graph and we're reflecting it, we're looking at the mirror image about the x-axis. It's a vertical reflection because all of the points are moving vertically. Now, if, on the other hand, we were sketching the graph of y equals f of the opposite of x, if the negative moves inside the function, so in this case it would be inside the square root. For the example of f of x equals x squared, it would be inside the thing being squared. Then we reflect the graph horizontally about the y-axis. And that's exactly what we're going to do with our next example. The next example is going to be h of x equals the square root of the opposite of x. Now here, what happens is we replace x with negative x, and when this happens, it causes a horizontal reflection about the y-axis. So we're going to be reflecting about the y-axis. So every point here gets sent horizontally to the other side of the y-axis. So this point that we have right here, 9, 3, becomes negative 9, 3. It moves to the other side. This point 4, 2 becomes negative 4, 2. The point 1, 1 becomes negative 1, 1. And the origin is going to stay the same because if we reflect it across the y-axis, it's on the y-axis, so it's not moving anywhere. And when we draw in the graph that connects these points, we've got a horizontal reflection because instead of going to the right, we're going on the other side of the y-axis and we're moving to the left. All of these points were reflected horizontally to the other side. These are called reflections. Before we had translations that were vertical and horizontal, and now we're looking at reflections that are vertical and horizontal. And in general, I want to say one more thing that kind of gives a little bit of a summary of what we've seen so far. If we have a transformation where we change x, so if x becomes x plus a constant, or x minus a constant, or negative x, this ends up being a horizontal transformation, either a translation, a shift, or a reflection. But then on the other hand, if we're taking our function f of x and we're changing that, so we've got f of x plus c, or f of x minus c, or the opposite of f of x, then what we end up doing is some sort of a vertical transformation. It's important that you recognize the difference whenever we're doing something that's on the inside of the function. We know that x represents the input. That's going to correspond to a horizontal transformation. And whenever we do something to f of x, like adding or subtracting or multiplying it by something, that ends up being a vertical transformation. And these rules are still going to apply with the transformations that we look at in the next lesson.